Okay, so we decided back in 2009 that the internet technologies used inside Google, inside Yahoo, by a number of our friends, it was time to bring a lot of those technologies out as a product to the mainstream. So we decided to build a new database, which is a bit crazy. We predicated our database on the existence of flash storage. We felt that in-memory technology, which has already been used in financial services for many years, with the advent of flash, we could now achieve higher levels of scale than had ever been done before, and use a lot of the clustering and high availability techniques that were already used inside the internet firms to achieve really some impressive results. So we started out to build a new database. Aerospike focuses on key value performance, although it also supports queries, and I'll show you how financial services firms in particular can use this kind of interface to achieve internet-type scale cheaply and effectively. It's also an open source system because we believe that open source is the new escrow, and we have the capability to ship a version that is open source, that is auditable, as well as having enterprise-grade features above that. So the architecture that I'd like to expose you to today, for those of you who are developing in these areas, is encapsulated in many ways by this one simple slide. What I have found as CTO is that the companies who have been achieving really impressive, unusual results focus on a stateless server architecture. So what says decisioning engine there is really your code and your application environment. Now, what some people have asked me is, why do we need 1 million transactions per second when, in fact, credit card swipes in North America are only running at often 10 to 15,000 individual swipes per second, at that's a high watermark over the course of several year period? Why would we ever need thousands upon millions of transactions? And the answer is simple, because what we are finding in today's analytics, what the Gartner analysts call HTAP, hybrid transaction analytics, is the fact that you may need hundreds upon hundreds of data points to be able to make an interesting decision about today's data. So with the ability to achieve millions per second, you as a developer now have the ability to make batch requests for your analytics, to store things like every single piece of traffic from every internet address in the world. That's only 4 billion addresses maximum, right, with IPv4. So the ability to do that in a 4 billion row table is now manageable. And that's what we've been seeing in some of our financial systems. The keys to succeeding at this is really to think about your batch analytics as being very separate from your operational system. And in this sense, there's nothing new under the sun. This is the kind of system that we've all been used to for many years. But with the advent of wanting to do more on that front edge, I think looking to internet technologies and internet technology stacks is a practical way to go. Some of the keys to this, first of all, are working with a microservices-style deployment environment. Microservices was a term originally used in internet companies where they originally had a monolithic application. They just wrote their application. If you're Twitter, you wanted to have a stream of user tweets, you just write an application, it's one application. But then they saw the ability to add a feature here, a feature there, a feature somewhere else. And so they said, well, each one of those features, you should have a development team that is making operational choices, that is choosing new databases, that is choosing new deployment environments that are suitable for that particular environment. When you do that, you have the ability to move faster in a more agile fashion, and that's what I have seen succeed in these applications. Key is allowing that development team to choose their own tools and their own languages for this kind of development. However, one of the keys to microservice style use is using at the highest level of your service, often with a REST interface, business-specific logic. The key is not to use and expose database primitives. I've seen that mistake made a few times. If you simply wrap your database and your data structures with an API, you will find that developers are then coding to an underlying data store, which limits your scalability in the long term. A business-specific logic with a microservices wrapper tends to be the path to success. Now, there's a lot of new technologies in these technology stacks, and they demand a certain amount of investigation. Typically, again, it is what your development team is used to, what they're capable of, what they know is often your best choice in these environments. So let's talk about some examples of how these kinds of deployments actually roll out in production. At Aerospike, we were able to take advantage of and be used in large ad tech deployments, mostly in North America, but also throughout India and Japan. In these cases, the name of the game is to be able to figure out and predict what advertisement is most suitable for a given user at a given time. The flows necessary to participate in the auctioning systems, and these are markets, essentially capital markets, but for advertising. These auctions are often flowing today at about 2 to 3 to 4 million auctions per second. Each auction is a separate advertisement placed on the internet. Each one of those auctions often has 100 different companies bidding on the ability to place an ad. In these cases, what is critical is having a few kilobytes of user data available for optimization. You don't have time when you are doing millions per second to look at much more data than that. So with those systems, you can in fact track every user in North America quite simply with a fairly modest-sized server system. Within retail trading, we have one customer, and what they were able to do, again, a key value approach is key here, is the ability to, instead of using a stream-oriented methodology, where trades in flight, you don't really know what they are, right? Because they're in your stream processor in an older style CEP engine, within even your Kafka queues in an internet methodology. You don't necessarily know unsettled trades because they're in flight. What one of our customers did was they said, in order to do proper risk management, we want to see all of the trades that are unsettled, because that is in fact the greatest risk that can accumulate moment by moment during the course of a trading day. So especially with today's complexity in trade settlement, where you must break down a larger transaction, a parent transaction, into a variety of children and settle them in individual systems, the ability to use a database underneath it is very useful both for fraud detection, which they do, as well as risk management, which now happens on a minute-by-minute basis, as well as starting to understand key metrics like the settlement efficiency of individual markets when you're trying to place child trades. All of those on a moment-by-moment basis using a database underneath and then of your stream system gave them some new and interesting capabilities. This particular example was a firm in London who is a partner of ours, and what they saw in a fairly standard trading environment was the ability to have a database that scaled as an in-memory system. What they were using really was a system that is clustered, that is a RAM-based system, and then built on top of it. And again, there's a lot of key value-oriented use here because there's individual ticker symbols, individual trades, recently settled trades on individual accounts. Again, focusing on that key value database experience technology is one of the best ways to achieve scale, instead of thinking of the kind of complex queries or graph queries that can give you a lot of capabilities and flexibility, but will have trouble scaling in the long term. We have a few people doing large-scale fraud prevention, and the interesting point that I've experienced here is moving beyond the rules engine. So what has been done in fraud detection previously, most of it has been generating through that back-end system SQL rules, and then executing those SQL rules moment by moment during actual transactions in the middle of card swipes. However, that doesn't get you the kind of agility that you need for today's fraud environments. If you would like to really achieve machine learning, which can't be expressed well in SQL, but also you want your developers and your quants to be generating much more interesting and rules than had ever been done with a SQL engine, using this kind of approach has allowed them to really achieve some numbers that are unusual. In this particular case, the ability that you'll notice here to get in-memory speeds at above hundreds of terabytes of online data. This is moment-by-moment in-card swipe territory accessibility with hundreds of billions of objects. What this means is successful projects that can, for example, track every internet behavior and use those behaviors when looking at fraud. For card not present, for internet capabilities, these kinds of capabilities at your data layer become a really interesting new environment. Some of our EdTech customers are using aggressive machine learning. And this was a slide taken from Nielsen. Nielsen Marketing does a lot of work in this. And what they found is the ability to have machine learning models that are in real time. So this is all real-time trained, real-time retrained, where every single minute they are retraining their models to do, in their case, audience classification. Now, that kind of data store, the data stores that support that kind of use come in two flavors. One is simple recent user behavior. For this kind of system, they, in particular, needed about 30 to 40 terabytes of online data. Imagine that HA replicated multiple data centers. What was interesting when I walked through them with this was the fact that they needed to also store their models. The model store for machine learning is an often underappreciated part of online machine learning. When you are building a model store that is changing rapidly, you need to monitor the effectiveness of those models. You also need to be able to checkpoint them so that you can roll back non-performing models. In this particular case, they were able to achieve 50,000 models that are being retrained minute by minute in real time to do audience classification, which is pretty cutting-edge technology. So this overall pattern, stateless applications, microservices, of course that's what internet companies do, but I suggest to you that getting your financial services customers or your enterprises working within this model is really an interesting problem. And so there are plenty of interesting cases that I've been exposed to over the last few years at AirSpike. And be very interested to talk with any of you approaching these problems at lunch. We have a table open for just discussing that. As a bonus, I'd like to talk for just a few minutes about flash and flash storage, because it has revolutionized the world of databases. Luckily, these days, we now have a technology called NVMe, those of you who are familiar with it. NVMe is now a standard that allows you to do direct attached storage at PCI bus speeds. So those of you who had been used to doing a PCI card add-in, it's now possible to do front panel attach and to achieve some pretty amazing speeds. The data center capabilities of these drives are good for high write loads as well as sort of a read-oriented data warehouse. Luckily, most public clouds now support this kind of flash as well. So Google has some very strong capabilities in this area, as well as the ability to have multiple devices per instance within their public cloud. Amazon, with their Generation 3, was very flash forward. They've actually moved back to using a lot more EBS, but have very strong instances, their i3 category, that are flash focused. All of these are really what enables having hundreds of terabytes online for this style of application, doing predictive analytics, doing trade negotiation, and doing new forms of risk. Now, what we've also started seeing is there's a new kind of storage called, from Intel and Micron, called storage class memory. For those of you who haven't heard of Optane, which is Intel's first product in this area, I recommend going and taking a look at it. At Aerospike, we've done quite a bit of work with Intel about how to adapt this to databases. We have found that this kind of technology, which uses essentially resistive storage, which allows melting and reforming of little pieces of metal inside a chip, and it's entirely new chip technology, has a capability of much higher write loads and much lower read impact of writes than has ever been done before at a cost that is a bit higher than NAND, but so much less than especially the power costs of DRAM. It's really allowing some new use cases to be approached. So hopefully the one thing you take from this talk is that there are new capabilities and cutting-edge companies out there putting hundreds of terabytes on the front edge of their applications to solve new problems in analytics. So, questions? Do you propose a migration tool to copy data from SQL from example to your database? I do not propose a migration tool because you have to think about your application differently. You can't just do queries anymore. This is for developers to do new things. When you have a tool that is 10 times faster at the data layer, you simply do have to start reimagining your applications. What are the expectations around retail banks' performance now? Well, retail banks do not have, in most cases, a lot of scale because the number of transactions they are processing is relatively modest. What I see is more applications in payment processing, in trading, than in retail banks. What are the challenges retail banks run into when implementing tech? That's a pretty broad question, and the answer for retail banks really focuses around what's the use case. Can I provide a better retail experience, and what's considered a database? That's what stores data. What's the biggest production cluster your clients operate in terms of number of nodes, RAM, and disk space? Aerospike is typically deployed when you want to put more than about 10 terabytes of application data, and that's replicated, usually multiple data centers worldwide. Our largest customers have hundreds of terabytes and hundreds of nodes. So thank you very much. Hopefully some of you will join me for lunch and talk more about the issue of trying to get these technologies into enterprises. Thank you very much.